So what to do for the substitution here? Well, 1 over something is a function. And so this is a chain kind of composition of functions where we have 1 over and then 6 plus e to the negative 3x. So I think the natural thing to say here would be, well, let's let u equal 6 plus e to the negative 3x. du is a little simpler because the derivative of 6 is 0, and I get negative 3 e to the negative 3x dx. Problem. I definitely see my u here, but there's no extra, there's supposed to be an x there, there's no extra e to the negative 3x hanging around here to work with that. We did have a similar problem like this where we just kind of solved for x in a problem like this. And I could do something like take this right here and solve for e to the negative 3x and say it's equal to u minus 6. That would be this right here. So I would divide all of this to the other side and say something like dx is 1 over negative 3 times u minus 6. And I already have a u here, so that means this integral would translate as 1 over u times this right here, du. I'm just going to pull the negative 1/3 out front. And then I have times 1 over u minus 6. You can't separate a product in an integral as two integrals. So now I have a quadratic in the bottom, and 1 over a quadratic is a problem because that's going to be 1 over u squared minus 6u du. And this would be doable by substitution if there were a u in the top, and there ain't. So again, I brought myself into a situation that's still complicated, and I'm not sure how to solve it. So here's the observation I made when I was playing with this one before. The du, it would have been nice to have an e to the negative 3x in the top. I have an e to the negative 3x in the bottom. So what I'm going to do is I'm actually going to do a little algebra on this. I'm going to multiply top and bottom by e to the positive 3x. So before I substitute, because this substitute did not seem to help, it made me only marginally better off, maybe. E to the 3x times 1 is e to the 3x. In the bottom, e to the 3x times 6 is 6 e to the 3x. E to the negative 3x times e to the 3x is what? It's just 1. So I'm going to get a plus 1 in the bottom. Now, if I let u equal that denominator, 6 e to the 3x plus 1, du is going to be 6 times 3 times e to the 3x dx. And the deal is that now I've got an e to the 3x dx there, and here I'm just missing the constant. And in general with substitutions, they only work if you're only differ by a constant multiple. So now I have a substitution that would work, and it turns out this time I had to just do a little algebra first. So I keep forgetting my u, my du, I'm going to divide the 6 times 3, so I would have 1/18 du is equal to e to the 3x dx. Shift this a little for some more room. Off a little bit, that's okay. So finishing my substitution here, the e to the 3x dx is now 1/18 du. So I'm going to pull the 1/18 out front. Integral 1 over du. And the denominator here, the 6 3x plus 1, that is my u. Antiderivative for 1 over u is the natural log of the absolute value of u. And u, remember, is just this thing right here. So now I have an antiderivative. It looks like it is 1/18 times the natural log of the absolute value of 6 e to the 3x plus 1, close the absolute value, add your constants. Side note on this one, e to the 3x is always positive, plus 1 makes it always positive, so I really don't need the absolute value here since the internal function is always greater than 0. Absolute value is optional on this one. Sometimes it's not.